Hi, Sensata trainee. Welcome to Sensata Product University's Functional Safety 101 course. We have designed this course to provide a baseline understanding of functional safety applications and the Sensata products that provide solutions to these applications. This course will help you identify these opportunities and provide knowledge to speak with customers with greater confidence. As mentioned before, in this training course, we will cover the basics of functional safety applications. We will cover how functional safety came about, what it is, how its use is being expanded, what functional safety products Sensata provides, and finally, some functional safety applications. Instead of jumping into what functional safety is right away, it might make more sense to provide the background on how it came about. Functional safety is a product of three different forces that are common in the industrial market. This is accident prevention, plant profitability, and insurance pressure. Catastrophic industrial accidents are a major driver of functional safety. Accidents like 3 Mile Island, Bhopal, and Deepwater Horizon put public and monetary pressure on companies to become much more focused on preventing catastrophic failures that were deemed unacceptable. A shift in focus on plant profitability is also a major driver. Plants became much more focused on reducing downtime in every aspect of the operation, including elements of the process that were designed around the safety of humans. Lastly, pressure from insurance companies and increased enforcement by regulatory agencies was the third major driving force. Insurance companies drove premiums up due to risk levels, which plants counteracted by making it safer for their workers. The culmination of the three major forces mentioned previously led to the industry creating harmonized industry-accepted standards of safety. CEN/CENELEC is a European Committee for Electrotechnical Standardization. The committee establishes standards for electrical equipment to ensure marketability. The committee established two different standards that would serve as pillars for functional safety. EN ISO 13849-1 is the safety standard that codifies safety design standards for control systems based on safety performance levels that resulted in a calculated risk reduction. This standard is referred to as PL or PL rating. EN/IEC 62061 is the safety standard that establishes the functional safety requirements and risk reduction strategies for machinery-specific aspects of a safety-related electrical control system. This standard is referred to as SIL or SIL rating. With the background of functional safety established, it's easier to lay out what functional safety is versus generic safety. Safety is freedom from unacceptable risk of physical injury or damage to the health of people or to the environment. Functional safety is the portion of safety that depends on the correct function of the process or equipment in response to its inputs. In other words, functional safety is the safety pertaining to the operation of equipment or systems. The goal of functional safety is to reduce the level of risk in a piece of equipment or system. Risk, in the eyes of functional safety, is seen as the severity of failure of the equipment or process multiplied by the probability that it will occur given the components of the system. SIL rating indicates how much the system is designed to reduce risk of failure. SIL ratings are referred to as SIL 1, 2, 3, and 4. With a SIL rating, no single component is intrinsically SIL rated. Instead, the system as a whole is given a SIL rating. SIL rated components help achieve SIL system rating with greater ease. To contextualize this, a designer may want to design a SIL 3 system. In order to achieve a SIL 3 system, the risk reduction factor needs to be 1 in 10,000. There are many ways to achieve this, but by using SIL rated product, the designer can achieve this faster and more efficiently. PL is the safety performance level of a control system. Like SIL, it indicates how much a system reduces risk, but it is more general. While SIL refers to machinery-specific electrically controlled system, PL refers to any control system. Also, like SIL, PL is a system-wide rating. Having a PL-rated part does not rate the system for a certain PL level, but helps the designer achieve PL system-wide rating. PL ratings are referred to as PL C, B, D, and E. Due to the design behind functional safety rated products, there is an inherent increase of control of the product. Functional safety product can be controlled so failure rates are 1/100th, 1/1000th, or even 1/10,000th of their non-functional safety counterparts. This decreased risk opens up new opportunities for applications. For instance, when a SIL encoder is partnered with a safety controller, it allows users to control a motor's speed, position, torque, and direction of rotation in ways it normally would not be able to operate. Shown here are some of the common forms of additional operator modes made possible with the functional safety encoder and safety control. Each of these functions allow for new operations that were either hard to perform or impossible to complete without the precision of functional safety product. The special operator modes open up unique opportunities for the factory to drive efficiency on the floor and with their employees. Safely limited speed ensures that the drive does not exceed a defined speed limit. Safe torque off interrupts power to the motor during the safety interval. This is the opposite of an uncontrolled stop, which relies on friction and inertia to coast to a stop. Safe stop 1 is a controlled stop with power available to achieve the stop, followed by removal of power when the stop is achieved. Safe operating stop is when the motor is stopped and brought into a position and monitored by the drive control to maintain that position, a safe standstill. Safe direction functions to ensure that the drive can only rotate in the selected direction. Safe brake control permits the safe controller of holding a brake. The safe brake control function is always activated in parallel with the STO, or safe torque off. Sensata has a number of different functional safety products available that can help the customer achieve the safety level they are looking for. Most of our functional safety rated product are encoders, which are position sensors frequently used with motors. The DSM-5X is a 58mm shafted incremental encoder that is IP69K rated and built for washdown environments. The DSM-5H and DS-05H are 58mm diameter incremental encoders sold in both shafted and hollow shaft styles. They are IP65 rated. The DSM-9H and DSM-9X are 90mm diameter incremental shafted encoders. There are aluminum and stainless steel shafted options as well as IP65 and IP66 ratings available. The DSU-9H and DSU-9X are 90mm diameter incremental hollow shaft encoders. Both aluminum and stainless steel versions are available. Functional safety is an ever-expanding requirement in many industries. Shown here are some of the applications that functional safety is becoming more prevalent in. In the next slides, we will review where functional safety makes new opportunities possible in these applications. A number of processing steps in automotive plants require periodic services to load up raw material and clear away production waste. It is not unusual to have an access door with a safety interlock to gain access to the machine in order to perform those functions. Without a safety system, the operator would have to hit the stop button, wait for everything to stop, and then usually also wait for a time delay before gaining access. With the Safe Stop 1, SS1, function that can be provided with a functional safety encoder and safety controller, the door can be interlocked to the Safe Stop function so that as soon as the equipment has reached a safe stop, the operator can have access to the service workstation. Since the motors are still energized when the door is closed, the process can start back up again immediately, saving valuable cycle time. Automated vehicles work side by side with humans and often operate with little in the way of barriers. Since they work so closely to other humans, the potential risk for collision and operational hazards is high. Mitigating this increase in the risk requires tight controls for the ground speed and directional control. Without a safety-rated product, the design engineers might have to add 2 or 3 redundant encoders in order to increase the level of safety. This costs both precious space and money. Using a SIL 3 rated encoder could eliminate the need for redundant encoders and can save the design engineer both space and money in their application. Cleaning food processing equipment before switching to different products is a time-consuming process. The reason it can be a timely process is because the equipment cannot be ran at full operating speed during the cleanup process due to the safety hazard it presents to employees. Using a normal encoder, plants would have to shut down the line to clean the equipment, but using a functional safety encoder allows for a more productive solution. Using safely limited speed, SLS, along with safe direction, SDI, the plant can run the equipment in a very slow, controlled fashion that allows the workers to continually clean the equipment as it moves, eliminating the need to stop the equipment before switching lines. Large, high-speed printers can be very dangerous. Typically, if there is a violation of safe space around the equipment, it calls for an immediate shutdown. The shutdown preserves the safety of the employees, but there is a commercial cost in terms of significant loss of processed product as well as equipment downtime. Using functional safety encoders, the printer can have different safety zones assigned to it, each controlled by its own motor in synchronization with the other motors on the line. If a worker were to violate the space, only the one zone would shut down, and the other non-violated zones could adjust their speed in such a way to protect their functions, but also reduce the commercial cost of a safety violation. Thank you, Sensata trainee, for attending Sensata Product University's Functional Safety 101. I hope you found the course useful and you learned a thing or two about functional safety applications and how Sensata provides solutions for them. If you have more questions or feedback on this course, please feel free to reach out to your Sensata representative. And again, thank you for your time.